Hello all, my name is Vignesh Iyer and I am an intern at Sparks Foundation. The topic which is given to me is supervised learning, and the task with respect to the topic is to predict the percentage score of the students on the basis of the number of hours invested. The type of the concept used in this is the linear regression. The reason I have written it now only is because I have analyzed it previously. So moving ahead, the first step is to import the libraries. Pandas, NumPy, Matplotlib, Cbon, and also one more extra library is there called as sklearn or scikit-learn library. These are the libraries which we are going to use now. The scikit-learn library I have imported it after in the further part, or we can say in the after part. So you will be getting to know about that in the next part. So these are some of the libraries which we will be needing. So that's why I have imported it. Next part is importing the dataset. The reason we import the dataset is to analyze the data, like its characteristics and all those things. So that's why I have imported it. So you can see that this is the dataset where we have two columns, hours and scores. That is, hours is the number of input part and scores is the number of output part, and it has 25 rows that's starting from 0 to 24. Nextly, we have to pre-process the data. So pre-processing data means something like cleaning the data, or else we have to fulfill the data. Suppose if any of the missing values are present in the data set, so we have to fulfill that by just predicting the values, like using mean, median, mode, or interpolation, like that. Or else even we can sort the data if any of the data are wrongly interpreted. So moving ahead, first of all, before pre-processing, we have to check for the shape of the data. That is one of the most important part. Like as I've said previously only, that we have 25 rows and 2 columns. So that is only written here. So shape is nothing but it interprets in the data set in the form of rows and columns. Starting is the row and end is the column. We can get a detailed information about the data set, so that's why I've written here df.info. Info means nothing but giving the information, so where we are going to get some information. Like range index is 25 entries, 0 to 24, as usual, as I said previously, that 0 to 24, so that means nothing but 25 rows. Data column is 2 columns, hours and scores, that is the column part, and the non-null count d type. That this means that there are no null values present in the data set. That means the data is fully filled up. No need of filling the data or predicting data. There are no null values or there are no missing values present. Ours has float concept, or we can say the values are in the form of float. As you can see here, ours has 2.5, 5.1 in the form of decimals. That's why we have they have written it here as float, and int is nothing but the full value, 21, 47, 27. That's why they have written here for scores as int. So moving ahead, we can get a proper description about the data through this code, that is df.describe, where the number of count 25 hours for hours and 25 for scores. The mean, they have taken the mean for this as a whole, so that is nothing but 5.01 approximately, and 51.48 for scores. This is for hours and this is for scores. Standard deviation, it is given as 2.52, and for hours, and for scores it is 25.28. It is for scores. Okay, so this is the minimum count, it is 1.10 for hours and 17.0 for scores, and maximum count is 9.20 for hours and 95.0 for scores. So we have checked for the description now. Now we can check for the means whether the null value is present or not. So previously only I said that there are no null values present in this case. No need of checking it, but still for the better practice I have written it here as df.isNull. This code checks for whether the null value is present or not. If the null value is being present, then at that time the output would be as true. But you can see that there is no true value present here. That means this is false. That means there are no null values. If there are no null values, output would be obviously false, as you can see here. So no need of pre-processing the data now. Fortunately, we don't have any null values or any of the wrongly interpreted values. So we can go ahead. We can visualize our model. So we can visualize it through graphs. First of all, I have plotted the scattered plot. Scattered plot, what does it do is like it checks for the data distribution of the data set. So how the data is being distributed. So in this case, you can see that the data is distributed through a linear regression part. Like as I said previously only that linear regression is going to be implemented in this graph. So you can see that the data is being distributed linearly. I checked for the pair plot. So you can see this is the pair plot where histogram is being implemented and also scattered plot is being implemented. Nextly, I used heat map, which is used to check for the accuracy. So you can just check here. One describes the skin color or light color, as you can see here, and black describes the 0.98 value. So you can just see this. So it is being written. So we can correlate the data through this. I have correlated it. Nextly, we are going to set the values, or we are going to prepare the values. So where capital X describes for this and small y describes for this. Nextly, the most important thing comes is to split the data set. So basically in supervised learning, we split the data set into test and train. So that only I have done here. So for that we use sklearn model. As I said previously that we are going to see first sklearn or scikit-learn library in the next part. So this is the part where we are going to use this. So this is nothing but xtrain, xtest, ytrain, ytest. I have splitted the values on the basis of that, and you are getting the values. So I have run this part. So next part is to train the model. So before going for this, I would like to tell you that after splitting, what we do. So after splitting, we are going to train our model. So training model can be done using the trained dataset. So as xtrain and ytrain are the trained dataset, so we can import that into our ML model and we can get an output with respect to that. Nextly, we are going to predict our value. What we are going to do is that predicting the value means we are going to use the tested value for that. So the input that is nothing but the X test, we are going to import it into the ML model and we are going to get the predicted value. So what we are going to do is that we are going to compare that predicted value with the tested value and we are going to come to a conclusion with respect to that. So we have trained the data. So as I have written here, training is successfully implemented. Nextly, we are going to see the linear regression concept through graph. So as you have learned this concept of y is equals to mx plus c previously in your previous classes, you might know that where m is nothing but the slope of the line, c is the intercept of the line. As you know that y is equal to mx plus c is the equation of the line, so c is the y-intercept. So y-intercept, what does that mean? When your independent variable, that is nothing but your x, when it is 0, at that time you get your y-intercept. So x is your independent variable and y is your dependent variable. If you'll compare it in terms of statistical data, so you will get that part. So m is nothing but the coefficient in terms of statistical part, and c remains as y-intercept only. That's the only difference where we are going to get like coefficient. So m you have got as 9.78 and your c you have got as 2.37. That means it's going to start from 2.37. So line is equals to mx plus c. This is the graph we have imported. We are going to check it. You can see that the data is being distributed. The same data which we have imported it for the scatter plot, we have imported here the data. So through the line we can see that many of the line are at an equal distance. I mean to say many of the plots are at an equal distance, and also the scattering is not that much in this case. Some of the means though there are some variations, but still we can say that it's a good model. So we have verified this. Now we are going to predict. Training is done. Now we are going to use the testing concept here. So ypred is nothing but model.predict xtest. I have imported the xtest into the ML model and I have got the output. So this is the output which we have got for ypred. Pred means nothing but This is for the predicted value. Okay, so next we are going to compare it. That means the actual tested value and the predicted value. So you can see this is the basic part. Mean test score is nothing but it is used for the y test, and predicted score is for y pred. So for 20, when it is 20, at that mean test is 20, at that time you are getting a 17. There is a bit difference in this. Okay, so we'll check for the second one also. 27, you can just say check it, you are getting a 33, large bit of variation. But see, if it would have been like 30 or 29, then we would have understood like there is a little bit of variation, but it's okay. But large bit of variation here also, you can see that for 69 you are getting a 74. Here also 30, for 30 you are getting a 26. Large bit of variation. So we can just check it through graph. So what I have done is that plotting a linear regression, and we can just check for the scattering. You can just see that the scattering is on a large scale. There is a large bit of variation. That's why all the scattering plots are far away from each other. You can just see from here to here, large bit of variation, man. So we have checked this also. Now we can check for the accuracy. So for accuracy, I have checked the score for train as well as test. So for train I am getting as 94.84, and for test I am getting as 95.68. So you can see that test is one value greater than train. So test is better as compared to train, but still both are good only, because 94 and 95 there is not only one value difference between them, but both are good. But test has a larger value as compared to train, so I am telling that test is greater, is good as compared to train. That's it. Next we have to predict the value. For prediction, what I have done is that I have taken the value as 9.25, as this is the task which is given to us. This is the major task which we have to. This is 9. When the input is 9.25, what will be the output? So when the number of hours is invested as 9.25, at that time you are getting the value as 93. So I have written the code for this. You can just check it. So you are getting the output as 93. This is the output. So nextly, I have to evaluate the model. So for evaluation of the model, what we can do is that I have used here mean absolute error concept to check for the efficiency. So you are getting the output as 4.41. So this is the code which I have written. So we have to import the tested and predicted value, and on the basis of that you will be getting the output, and we can check for the efficiency. So this is the evaluation of the model concept which I viewed. So this is my model. Thank you very much. Hope you have enjoyed this.